First Spin. Welcome to First Spin, a show where I learn how to use the parallax propeller without having any prior programming experience. And rather than do this on my own, I have enlisted the help of two...
No, we're on strike.
What? You can't be on strike.
No justice, no peace.
I'm not on strike.
Oh, solidarity. Scab!
Well, you should have mentioned it before going on the air that we were on strike. You
now that you
just now.
Exactly. Now that you've started and after the first spin sound, you can't go back on your word.
Well, I'm willing to come to the negotiation table.
Let's negotiate altimeters today.
Okay.
All right.
As long as you make me cookies later.
Arguable. Oh, sorry, no flour.
Oh, come on. Imparting ancient microcontroller wisdom just for cookies, I think it's a fair price to pay. Roy, you just get a high five.
High five.
Yeah, no cookies for me.
I see. Well,
we pay Roy in high fives.
Should I go through the whole list of things that we've been through?
No. We've covered a lot of them. They're all on firstspin.tv.
It is
all
true.
the different modules and all of the different programming stuff. But
and most of them are also on learn.parallax.com in the Kickstart section.
Correct.
Yeah, the Kickstart stuff that they're doing is really cool.
It's actually, I feel like I'm cheating.
So much easier than when I picked up the propeller and started because there wasn't as much.
You don't have to reinvent the wheel.
Right.
So, okay. So today we are going to be looking at the altimeter module. I believe this is MS5607. Yes, correct.
So Addie, can you teach us what an altimeter module is?
It can measure the altimetry. Altitude.
Yeah, but don't use the word in the definition.
It's technically measuring the pressure.
And basing the altitude off of that.
So the basic idea is that the higher up in the atmosphere you go,
the lower the
less pressure because there's less air over your head pushing down on you due to gravity.
Correct.
Yeah, that's why I have a headache all the time, is all that air pushing down on my head.
Yeah. When we brought Roy up in the mountains, he was just floating around. He was like, less pressure, man.
It was happy
style.
Times at 5,000 feet.
Might have been that bad hot dog we had on the way up, though.
But whichever. All right. So yes, this is a it's technically an altimeter module capable of measuring altitude, but because its method of measuring altitude is through barometric pressure, it also has barometric pressure sensors, and it has a temperature sensor.
I'm assuming it needs the temperature.
It's all one sensor
to be accurate.
Yes. It's temperature sensitive in the way it measures things, so you need to factor in the temperature when you are reading it so that you can get an accurate reading.
So it's the temperature of the chip, not ambient temperature.
Well, it is the temperature around this board. It might be a little bit away from ambient temperature, but it's going to be pretty close in this particular case.
I see.
It's also light sensitive, and you're probably going to wrap it in something to make sure that it doesn't
completely wrap it because it's got to be open to the air pressure.
Yeah.
You typically just put a shield over it so it doesn't get direct sunlight. Because the direct sunlight will cause it to get a higher temperature reading, which will cause it to be out of whack on its readings.
It also looks like it's water sensitive.
Well, yeah, because it's got, if you look at it, there's two little holes on the chip there.
Yeah.
Because that's where the air pressure gets measured. And you don't want water to get in there because it'll plug it up.
That makes sense. And
that would be
add
bad.
all sorts of...
Well, you generally don't want water to get on your electronics.
Right. Well, obviously.
It lets all the blue smoke out.
Right. Obviously. But this is the first time I think that I've noticed the water droplet ixnay symbol on here. So, interesting. Okay.
Well, yeah, a lot of circuit boards, they can get wet as long as they're not on and you dry them off quickly, they'll be fine.
Right.
But if there's holes in the IC, obviously that's a no-go.
That's a different thing.
Yeah.
Interesting. Okay, so we have the ground pin that we know V in. The power can work from 3.3 to 6.5 volts.
Oh, you guys remember a couple weeks ago when we were talking about VSS and
yes.
VCC?
Yes.
And VDD.
Yes.
We forgot one.
What?
VEE.
And what's VEE?
That's the ground for the old 5-volt logic, the TTL level logic.
Oh.
So there's one that you don't see too much these days.
Yeah.
So
Okay.
yeah,
Well.
little amendment to
side
that
note
episode there.
Gotcha. And then we know the SCL SDA, that's for the I2C clock and data line. But we have new PS, SDO, and CS. So experts.
So this particular module is able to operate in either I2C mode or I2C mode or SPI mode. And with SPI mode, the SDA pin is actually also an SDI pin for input.
Okay.
And then SDO is the output pin. So with SPI protocol, you have your input and output on separate pins.
Okay.
And then you have your CS for chip select, which is saying this chip is the one I want to work, because you can share the signal lines with other chips, and then the chip select, only the one that has chip select turned high is the one that will work.
I see.
And so then the PS pin is just choosing between whether it's I2C or SPI protocol.
Now, is SPI the one that they use in those little those chainable thermometer chips?
Possibly. I mean, it's...
Or do they use
SPI
I2C for that?
Well, SPI is just an alternate serial protocol, you know. It's just a different way of doing it.
It's one of them newfangled ones. Get off my lawn.
Right. Well, see, SPI is typically you got 3 wires because you have your clock, and then you have a separate I input and output pins. Whereas I2C uses 1 pin for both input and output.
For the data line.
Right. So that's the SDA is just both input and output.
Which one is it that can do 1 wire? Or is that called 1 wire?
It's called 1 wire, as far as I'm aware.
1 wire can do 1 wire?
Yeah. They actually have one that runs on just a single wire.
That's cool.
Yep.
Which is absolutely magic.
Yeah.
So it requires cooperation on both sides to work.
Yeah.
Right.
Yeah.
So I pretty much ignored the SPI business because whatever.
Because you don't need to use it.
Right.
You can just, by default, it'll work in I2C mode.
Right. So all I did...
She was more interested in looking at what the module does and not like how it communicates.
Right. So I just used
I thought I'd bring it up because, you know, they're interesting. Good to know anyway.
Yep. So we connect it up, and then we get to go to the Kickstart code for this module. Yes?
Yep.
Okay. Lovely. So it's using Parallax Serial Terminal for its serial terminal communications. And there's a new object, 29124 _ altimeter. And we'll go over that in just a little bit.
And just a little hint, that number is just the part number at Parallax in the store.
Right. I think if you look up 29124, you'll be able to find it.
Altimeter module. Yeah.
Yep. So we have pin 4 is the data line, pin 6 is the clock line. Those shouldn't be
well, they are commented out because the altimeter module code has some defines built into it. If you notice when it calls alt.start down there, it has alt pound quick start.
Yes.
Which is saying it's interfaced on the quick start board, and the quick start board by default will use pins 4 and 6 for the SDA and SCL lines.
I see.
They just the altimeter code,
the object code.
Right, the 29124 altimeter spin file has the pin numbers defined in it for various Parallax boards, and you just use the start command with the different name of the board to get different, different pin assignments.
I see. Okay. And then the XInFreq should be 5 million clock cycles.
That looks like it's just a typo on the webpage.
Ooh, we should tell somebody about it.
Yeah, you should email Ken or somebody at Parallax and say, hey, there's a typo.
I will do just that. And then start _ altimeter or alt. Now, this one, this is so your starting altitude in feet. That way, whenever you move,
Right.
it'll know because you've quote unquote calibrated.
Right.
To
so you
that.
have to tell it what your altitude currently is,
Right.
because it can't really deduce that pretty well from just straight pressure readings, because obviously barometric pressure changes with weather and all kinds of other stuff. So what the altimeter is really giving you is a relative change.
Mm-hmm.
So
Right.
you have to tell it what your starting altitude is. So you
Right.
kind of need to know what your starting altitude is when you run the thing.
Right. And if you don't know, you can actually look up your local airport, and they usually have the altitude. So then that's what I did. I just looked up the Rochester airport and looked up the altitude and then plugged it in to that.
What do you think would happen if we all got together and like all emailed somebody inappropriate at Parallax with the typo information? Like 100 people all emailed Bo Schwabe and said, "There's a typo on a Kickstart page."
Well, I don't know.
Just to let him know we're all thinking. No, he wouldn't, and it's really not his job. But at least he'd know we're thinking about him.
Yeah, although I think it'd probably be best to email, somebody in charge of the web pages, or maybe somebody who does the Kickstarts.
Right.
Like Gordon McComb, maybe, who doesn't really work for them, but does all these Kickstarts for them on contract basis, I assume.
Yeah.
Or something like that. It looks like it's just a minor typo.
Yeah, I'm sure it is. I just noticed it as we've been going through. So
anyway, another way to get the starting altitude, which is what I plan to do on my quadcopter eventually, is that you can use your GPS reading.
Ah, sure.
And get an approximately correct altitude to start at.
Yep.
And then you can use the altimeter's readings to give you relative difference from that.
Right.
And the altimeter has like a 20 centimeter accuracy, and GPS is not nearly that fine of a grain. How accurate is GPS for altitude?
It's probably several meters.
Yeah.
Right.
So it gets you in the ballpark.
Right. As long as you're within an appropriate, plus or minus, 10 or 20 feet in altitude for the start, then the pressure changes will be pretty accurate. I mean, there's going to be a big difference if you tell it it's at 0 and you're really at 2,000 feet, right? You're not going to get good readings. Or if you're at sea level and you put in 2,000 to start with, then it's going to be kind of wonky.
Right.
So you want to be in the ballpark with your start altitude, because obviously if you get to read your airport altitude, that might not match. Like for me, the San Diego airport is basically at sea level, and I live up on a hill, so I'm at like 500 feet.
Mm-hmm.
So I'd have to put in a different value than what the airport is.
Roy likes to feel like he's above everyone else.
Well, if you're out in like Wyoming, then you could get the airport altitude, and it's probably the same for you because big giant flat state.
Maybe he's like the guru.
I've been to Wyoming,
Mount Roy.
And there's a lot of mountains.
It's true.
Okay,
Yeah.
Maybe I picked the wrong state.
Yeah,
you guys drove through a bunch
you
of
should come
Nebraska.
over the mountains sometime, Ryan, actually.
Nebraska was the flattest?
I think so. All right. But anyway, back to
Not useful. The altimeter, not so useful in Nebraska.
No.
Well, it would be useful if you were like in a flying craft going above the ground, then
right. Or if you were in Nebraska and super bored and decided to send like a balloon up in the air with like an instrument package or something.
That'd be fun.
Yeah, that would help kill the time.
Yeah.
In Nebraska.
All right. So
in Nebraska.
So the function is called start with the local variable of A. We start the serial terminal, and then we do altimeter or alt.start, and then we do alt #quick start, alt #background.
Right, and the quick start is just selecting the quick start board on the Kickstart page. They show you how to wire it up with a quick start for the propeller. You can also, if you choose to, you could use demo board or backpack or spinneret. There's various boards defined in the 29124 altimeter spin object.
Right.
So you can just pick the board that matches yours and put that there. And then the second parameter is telling it to just run in the background, reading the values of the pressure and all that, so that it's just constantly updating in another cog. So it's starting another cog to read the altimeter and keep reading it in the background.
Yep.
And then you call these other commands to read out the current values.
Right.
And that's the beauty of the propeller. You can have it be off doing it in another place, and the information is just there for you.
Right.
Yep.
And then so we set the resolution to the highest. And
right.
I'm assuming that whenever I see alt hashtag highest or quick start or background, those are all things that are referenced in the object.
Right. So inside of the alt, the 29124 altimeter spin file, these keywords, the quick start, highest, and background, are all defined in there to special values that mean something to that particular module.
Right.
Right. They're just in a con section in there define special values.
Right. And then we set the altitude, and we want to do it meters. Do it in meters, I believe. And then get the altitude in centimeters, I think. Alt dot average pressure, and then put that into the altitude.
Right. So when it reads the altitude, the raw altitude data, it's going to be in centimeters. And then when you print it, you use their handy dandy format command, which will convert it into meters or feet or whatever you want. You tell it to it by the alt hashtag.
I see.
So the A variable, the local variable A,
I see.
is still, it's going to be in centimeters. So it'll be like, several thousand centimeters if you're way up high.
I see.
And then it'll translate that down into meters or feet using some math inside of the format command.
And that's actually where we see the print pst.string alt.formation A, alt meters.
Well, it's format N.
Et cetera, et cetera. Format N. Oh, format in, I see. So go from meters to... Well, go into meters. Go from centimeters to into meters.
To convert it to meters, right?
Right. What's the CECR? Do you know?
Well, let's go look over in the thing over here.
In the 29124 altimeter.spin.
It looks like it is E0, which I don't know what that means. It's probably a combination of doing a carriage return and a clear line.
I see. Okay.
And, something along those lines.
Okay.
It's a code I'm not familiar with, sorry.
That's okay.
But that's what it looks like.
Okay. And then 8 and 17 are ASCII characters, I'm assuming.
Yeah, need to go look, sorry.
That's fine. All I know is when I ran it, it gave me it said altitude, and then said the meters, and then it gave me the feet.
Right.
When I started Ray for the podcast today, I might have used the wrong start altitude.
Oh, the that number afterward is the length that it will format the number into. So it's like the maximum length of digits that it will show.
Oh, 8 and 17. 17 is quite a bit.
Yeah, I guess they figure it's going to be a lot more feet than it is meters. Because meters, there's 100
sure.
And feet, there's, 20, 30 centimeters.
Sure,
so
that
makes more of them.
That makes sense.
And it's gonna show fractional values, I assume.
Okay.
But yeah, so it's just the width of the space to show how many characters.
Okay. And then if pst.rxCount, then px.receiveFlush, and pst.car pst#cs.
Right, and that's just like it says there's if they press a key, then clear the screen. Okay. So CS is to clear the screen.
Oh.
So it's just if you've hit a key, which RX count will be greater than 0 if you've pressed a key on the serial terminal input, then it will flush the read and clear the screen.
I see. And the CS, you would know to use that by looking at the parallax serial terminal object.
Right.
Hence the PST hashtag.
Right. So the pound
CS.
means something that's inside of the PST, and it's usually in the con section because you're referring to constants that are defined up in there.
Right.
So yeah, that's what the pound does in this context.
Gotcha. So, when I first ran this, I just ran it to run it. And I was a little, because of all the hashtags and all the complicated looking stuff, I was kind of, it was anticlimactic for me because I was like, oh, well, where's all the other information? Because remember, this has a thermometer in it. It also has barometric pressure sensors in it. So much like the GPS module, I wanted to see how I could take that information out from the object.
Right. So you went digging into the altimeter spin module, the 29124, and found other functions you could call to read out values.
Right. And so some of the things that I noticed were sea level pressure and what else?
Current temperature,
current
pressure.
Right. So I pretty much studied it, and I guess we'll go to my code. Is that okay? Okay. So we went to... So my code, I think, looks much nicer. All right? I'm not going to lie. I think it looks a lot prettier.
Oh, Roy, our little birdie has left the nest.
He's starting to be less of a noob and getting closer to the expert side of the spectrum.
Isn't that cool, though? It looks just so pretty.
I think that means you need to buy a sports car and I need to join a book club.
Probably. Maybe some crocheting.
Empty nest.
I know. So objects, I use the same thing. I use parallax serial terminal and the altimeter object. And I got the Exenfreak correct this time. Starting altitude, I guess we're a little higher than the 200 feet. We're at 1317.
Where you're at, yeah.
Yep. And then, so I started a whole bunch of I looked at the code to determine what was modular, how to get it shown, I guess, in the serial terminal. So I did pst.start, and then I think I probably decreased the baud rate from...
You used 38,400 instead of 115,200.
Right, because I didn't care that it updated that fast. Right. Although 38,400 is pretty fast too.
Oh yeah.
And then I started, and I used the quick start. I used the prop BOE board, but I used the same pins as the quick start. So I just said Alt pound quick start.
Yeah.
Did the highest resolution, and then set the altitude, the starting altitude. And then A was alt plus dot altitude, and then did the average pressure. And then I did a string that said altitude, and then I
put the altitude in meters of feet, just like they did.
Right, correct. And then...
But then you read the current pressure.
Right. And then I do the exact same thing.
Right, except that you output it in millibars and inches.
Right. Because those are the ones that are
meaningful for pressure.
Right. And
then you read the temperature.
And actually, you know what I think it is?
You shall, of course, put this code up in the description for the show.
Right.
Yeah.
So, the 8s and the 18, the 8s and the 27s at the end, where you say it's how long that line is?
Yeah.
It's how long the length of the line, the entire line is, from the beginning of the screen to the end of that line.
It's tabbing it in over on the other side.
Right. So it's like it's like putting 8 spaces before saying your thing.
Right.
Or putting in 27 spaces before. Well, I'm just now realizing that, because I thought it was the answer had to be within 27, but it's actually spacing in 27 and then talking. Right. Does that make sense? Yeah, okay.
Yeah, it's just formatting the string and positioning it in the appropriate place in the line.
So it's not ASCII.
Right.
Okay.
It never was ASCII.
Sorry. Yeah. So for those who heard my ASCII enthusiasm, it was an ASCII.
There's an ASCII character for tab.
Well, no,
There is,
I know that, but in this
it's the number of
context.
spaces.
Right.
Mm.
Correct.
On the format command that's in the Altimeter module.
Correct. And then the temperature, then I did temperature alt.current temp. And remember that current temp, current press, press altitude. That's all from the looking at the function name of the altimeter object.
Right.
So then I pretty much did the same thing, just looked at what appropriate temperature units it would be. So degree Celsius, degree Fahrenheit.
Right.
And then I kept the last portion the same.
Where it clears the screen if you hit a key. Yeah.
Right. And voila! It's beautiful. And it's
Right,
so
it
much
prints out-
neater.
You got your temperature and your height and your pressure all in there.
Right. And I know that there's another bigger demo with that you can find, I think, on the product page. And I ran it, but I didn't really like how it looked.
Yeah,
So-
you're kind of picky on the looks part of it. Yeah.
Well, you have to be.
Well,
there's-
some people are.
there's-
Some people are less picky.
There's art and there's neatness in code, right?
Yeah.
And there's art and there's neatness in the serial terminal. So you might as well go with it, you know?
Okay.
Yes. Anyway, so I was very excited about this stuff.
Mm-hmm.
Yeah.
I think
So that's-
aesthetics in code is a really good thing to
Oh, yeah.
get into early on.
Oh,
Right.
look, I did find out what alt pound CECR is. CE is clear to end and CR is carriage return.
Okay.
Oh, man. I'm a little impressed. I'm not going to lie.
Clear to end and carriage return.
Addie's impressed with herself again.
She must be easily impressed.
Look at it. Isn't it gorgeous?
She's impressed by her
I
own
hope you guys-
humility.
I hope you guys look at the code because it's so much nicer. You know, comments, I think if comments are actually say what is going on, like truly give you a good idea of what is going on in that line, unless they are doing that, they are completely useless and
Mm.
completely just mess up the look of your code.
You like a very clean look on your code. and-
Right.
yeah.
I don't mind comments.
They
but like,
have
for
to
instance-
be for good reason though.
Right. But like the Kickstart
Like, you know,
code.
you see a comment and it's like the bite walked blissfully through the woods.
Yeah,
Searching for no, none of that.
Completely useless.
Nobody cares.
Right. Exactly.
Right.
And I understand why they put the comment before the code in the Kickstart program, but to me that just I'm like, whoa, comments everywhere. What is this?
I'm used to it that way too. I prefer to have it right before the piece of code that it's
Oh
describing.
man, can't do it.
I like to read along and pick up the logic of what's happening and then strip out most of the comments, replace them with my own, and change all the variable names to better ones and, strip out 90% of their code because it's inefficient. And, but that's because a lot of it's tutorial code. It's designed to go through it in a very, obvious, very step-by-step way. And then you can always make things a little bit better with things like recursion and whatnot, which you would never include in a tutorial. If you could absolutely help it, you would avoid, right?
Right.
But as Addie so eloquently explains, expert, we do things a little bit differently, and our code can be beautiful.
Right. So that is that. Highly exciting. I like the Altimeter module. I like these modules that are modular.
Seems like it'd be pretty easy to make a barometer with it,
objects.
Yeah.
Yeah. Well, it is. I mean, that's
Mhm.
essentially what it is.
Essentially what it's doing there.
Yeah.
So, we don't have a barometer in the house. You should get on that.
Maybe I'll make
Get
a
a
weather
little
station.
Well, it's
You
fun
gotta get a
project.
little LCD display or a little 7-segment
Ooh,
No,
display.
she's got XP. She could just have the barometer in a box, and it could be transmitting the air pressure at all times.
So if all of a sudden there's a sudden decrease in pressure, isn't that when tornadoes hit?
We could have little alarms all over the place that would all get their XP signals.
Tornado coming.
I don't think I have to worry about tornadoes here in San Diego.
Probably
No,
not.
the worst you guys have to worry about is good weather.
Oh, we get earthquakes every once in a while.
Yeah.
That's true. You guys are California.
Yeah. I think the only thing I'd be worried about out there is my neighbors.
Yeah, there's that too.
Why?
Crazy
Zombies?
people live in Southern California.
Oh, true. Good point.
Except for me, I'm not crazy
Right.
most of the time.
Right. We're not saying anything.
Thankfully, we're out of time. So, that's all we have time for this week.
Yes.
And we put up a show every Tuesday at firstspin.tv.
Correct.
So if you guys pop back next week, we'll have more information up on the next great Addie adventure into learning how to program microcontrollers and, teaching us a thing or two as we have to look things up because she asks esoteric questions.
Yep.
All right. That's it for us for this week. We'll see you guys next week.
Bye.
Bye.
See ya.